Morning everyone, myself Uday. They will be conducting the experiment with refrigeration. This is a vapor compression refrigeration, right? As you can see, every conventional refrigeration contains 4 various processes. One being the evaporator, where you actually keep your thing that you need to freeze or reduce the temperature of. We have a compressor, which increases the pressure and the temperature of any fluid. In this case, we are using R134A. Then we have the condenser, where the refrigerant is cooled down, and we have expansion valve. As we can see in the refrigerator rig, 2 throttling devices, one being the expansion valve, which is the center, which reduces the pressure and the temperatures, and this is the capillary tube. So 2 throttling devices, we can either choose one of these, but for the experiment purpose, we need to connect both of them in the capillary cord. We can control the throttling valve by switching this switch here as into capillary tube or expansion valve. For this test, we are reducing temperature of water. So we have to keep water almost half kilogram, which is half liter of water, in a cup like this kind, and put this thermocouple inside it, so that thermocouple can measure the temperature of the water. You have to make sure you have to put this for at least 1 hour, so that the water cools down to sufficient temperature so that you can have a proper calculation. As you can see here, we have 5 different temperatures, each one for different stages. One being T1, which is after the evaporation, T2 being after the compression, T3 being after the condensation, T4 being after expansion, and T5 which is inside the freezer. That's the water temperature that we are seeing. We use all these temperatures to calculate the actual COP, the Carnot COP, and all. So we have to note down the power input to the compressor in kilowatts: T1, T2, T3, T4, and for T5 we have to switch between this model to T5, which changes the same, which shows your T4 and T5. We also need to write down the pressures, which is the pressure after the compressor and the pressure before the compressor. Using the pressure values that you found before and after the compressor, we have to make sure we have to match it in these lines by adding the atmospheric temperature. We need to trace a line till the point of it touches both the saturation liquid line and saturation vapor line, and need to draw a graph of a Carnot cycle, which I'll show you in the future.